BGE Physics. Welcome to another episode with Mr. Bull here as we revise Key Area 3 Energy Part 2 this time, and I hope you're ready because this is going to be a good one. Lots of things to get into here, so let's get cracking. Right, so we've got 4 things to talk about: conduction in liquids and gases, convection and radiation, energy sources, and climate change. So much to talk about. So let's first of all talk about conduction in liquids and gases on page 43. So you can turn there on page 43. So all of this stuff's going to be lots of experiments to talk about here. So I'm not going to actually go through the depths of the experiment, just very briefly, and talk about the conclusions of the experiment. If you were there for them, great. If you weren't, then just see if you can understand the things that I'm saying as a conclusion to the experiment, and hopefully that works out. Okay? So, first thing first. We're trying to find out, we know that conduction last time was a good experiment for solid, because we know that solid heats things up via conduction. Something hits something else beside it particle-wise, and then it goes along the line and it heats up really nicely via conduction. But what happens when liquids and gases are heated? Does conduction work for them? And so we used a test tube and a boiling tube where we had a thermometer down at the bottom and we had a thermometer at the top, and we added hot water to cold water, just dribbled it down the side, and we saw, was there a change in the thermometer values for the top one and the bottom one? What we found out was actually there wasn't. There wasn't much of a difference, because we knew that conduction from the hot water didn't come all the way up to the top. All right, it was very, very slow, and we could conclude that water is a very poor conductor of heat. All right. So then, what happens to gases? Well, we did the same for gases. Very similar experiment to conduction through a solid, where we had all the pins in the copper, and then we had this time a gap of 5 centimeters to another copper with a pin on the end there. So we had a gap where a gas would be air, and we'd see, is there going to be a conduction a lot across the gas? So that means this one falls off. Okay, so that's what we're saying. Does that work? And again, what we found out is that the pin took very long to fall off. In fact, sometimes people didn't see the pin fall off at all because the heat could not travel through the gas. All right? And this demonstrates that heat does not transfer through gases by conduction. We have water, very poor conductor of heat, and then we have gases, which does not transfer through conduction, or does not transfer heat through conduction. So we can kind of conclude that gases and liquids are very poor conductors of heat and are not as good as solids. But there are another 2 forms of heat transfer: convection and radiation, which both solids and both liquids and gases are very, very good at, and much better in this way than conduction. So we know that heat can travel through liquids, but conduction does not happen easily. So we know that heat travels, but what's the thing that's actually causing it to move? So there was 2 experiments we did. We had one where we had aluminium particles in a boiling tube with some water, and we heated up the water by just holding the test tube. All right. And once we held the test tube, we were seeing that the aluminium particles were rising and then falling, and then rising and then falling, and then rising and then falling. All right. So there was something going on in the water that was causing it to go up and then go down. We then did a second experiment with dye crystals, where we dropped mead crystals into the test tube, and we saw that when we were heating the beaker here, the water was starting to move. Okay, the water was moving around, so the water was going up, and then the water was going down. The water was going up, and then the water was going down, and so over time it changed color because the dye crystals were moving around the liquid. All right. Now, what could we say in conclusion to all of that? Well, what we said was that this heat transfer things, the water going up and then down, the water going up and then down, was convection. And actually that movement is called a convection current. Okay? Now, what actually is a convection current? Well, it's when warm liquid, which is less dense, which is how much stuff's in there, so it's less dense, rises up to the top. But when it rises to the top, it gets colder, so it gets more dense, and so it then goes down to the bottom. And then it heats up, gets less dense, goes up to the top, and then gets cool, and then gets more dense, and then comes back down. And so you see there's this movement here called a convection current that's due to the density of the air, of the water that you're heating up. All right? So, in summary, convection is the name for heat transfer in liquids and gases, much better than conduction. We'll leave the conduction to the solid. Okay? And as the particles heat up, they become less dense and move upwards, and then when they cool down, they go down. All right? So that's how we see convection works very well in liquids and gases. Now let's talk about energy sources. Now we're going to talk about a whole bunch of energy sources that I know that you'll know. In your head, you'll know them. We talked about in the first video 8 different energy sources. Some of these are those energy sources. Okay? So you'll know some of them, but you'll not know all of them. And we know that electricity comes and something that we need for our day-to-day lives, and it comes from lots of different sources, but this is a secondary source. Electricity, we can't just get electricity from a source. We need to take another energy source and use that to get electricity. It's what we call a secondary energy source. And so when we look at this here, what we see is that electricity is being made here, but if we go back the way, we start with something like an energy source like coal, like chemical energy. And we burn coal or oil or gas, which is what we don't want to do anymore, and it creates some sort of heat, which causes this water to steam up. That steam then turns a turbine, that turbine then turns a generator, and that generator produces electricity. So we can see that this is a process here where something's burned, but we also know that when we have renewable energies, we take this process away, and we actually go straight from the renewable source to electricity. And that's why renewables are so important. So, we know that there's 2 types, renewables and non-renewables. I've been talking about it. But what actually are they? Well, renewable energy comes from something that's natural, and it's also something that will not run out quickly. All right? And we know that it includes sunlight, wind, wave and tidal, to name just a few. All right? We also know that renewable energy is one that, as I said, does not run out. Okay, so we can use it again and again and again and again and again and again. Examples are solar power. And we know that solar power is on places that are very hot. So we have nice solar panels, higher physics, we talk about what they actually are. But we know that solar power is normally in a lot of hotter countries, not necessarily Scotland. Okay, even though we do see sometimes solar panels in Scotland, we don't often use them. But they use the light energy they get from the sun and they transfer that to electrical energy. Okay? And that's again more hot countries using solar panels. Wind energy is something that we're more used to. Scotland is very windy, and we have the turbines move around, and we know that kinetic energy changes into electrical energy. And you should be very aware of that in this school, because we know that we have the Whiteley wind farm just next door with 215 turbines, 539 megawatts of electricity being made, and most likely your home being powered by one of those turbines. All right? So be thankful that they are just there, because they are powering your home right now. And this is a photo of the turbines, okay? So you'll be recognizing that very clearly. Now, waves is also another way that we can harness energy, but we don't often see wave machines. It's very few and far between, but they can use the energy they get from the waves, moving up and down, to harness energy, electricity, that then they can then send back to the mainland. Now, we also know that on the other side of the coin we have fossil fuels, which we're trying to get rid of, we're trying to move away from. And we know that these are coal, oil, and gas. We also know that things are like nuclear power. All right, now nuclear power is a non-renewable source, but it's not as bad because it doesn't produce any of the emissions that we see from coal, oil, and gas. Okay, so we know that that's coal. That's what coal looks like. We know that oil and gas come in barrels there, or we extract the gas from pockets underneath the Earth's surface. And we know that nuclear power, maybe kind of looking back to The Simpsons a little bit, we see that the nuclear power plants are there. Again, they're not as bad as the fossil fuels, but they do have their things that people may not want to use them. So a wee table to finish off with all the renewables, all the non-renewables. We have things like wind, hydroelectric is something that we use as well in Scotland. But things like geothermal, we don't have any geothermal activity, so we can't use that. But we can use some. And then the non-renewables are there as well. So that's how we summary of that part. But now we need to go on to the most important topic, and that is the topic of the year so far, and it's climate change. So we know that there's a COP26 happening. Lots of leaders are coming to discuss the future of our climate in the world and how we can group together in order to stop climate change from happening and to having a detrimental effect on our world, okay? Because it's having a very detrimental effect to our world right now. So we need to save the Earth's environment and save non-renewable sources, but we also just need to save, I think most importantly, our ecosystems, our livelihoods, people's lives right now, because they're being affected by climate change. So, we know that carbon dioxide is bad. We know that we don't want it in our atmosphere. We know that it causes damage. We know that it adds to climate change. We know that it pollutes our atmosphere. And we know that we need it, or it's a byproduct of creating electricity, but we don't need it. It's not something we want. Okay? Now, we know that CO2 builds up in our atmosphere and it heats the inside of our atmosphere. So the heat energy gets trapped in here, can't escape, so it just gets warmer and warmer and warmer and warmer, and then our temperature starts to increase, and even by a few degrees that can be extremely dangerous for our planet. So we know that global warming is also called a greenhouse gas effect. You may have heard of that, and it's just the idea that it gets warmer and warmer and warmer due to the fact that we've got more CO2 blanketing the atmosphere from it escaping up to space. So we know that the negative effects of climate change are things like ice caps melting, and we know that we can see this already, that the water levels are rising. People are experiencing having to move away from their homes due to the fact that the water levels are rising in certain places, and that will continue to happen if the ice caps will melt. We also know that if ice caps melt, loads of habitats are being destroyed from that, and that's actually a very, very, very awful thing for some of these animals. We also know that it's causing a lot of heat in certain places, and people's livelihoods are being destroyed, and people are dying because of the heat that is in some of these places due to the increased temperature around the world. And we'll see that the temperature is starting to rise very rapidly in a lot of the countries in the kind of along the equator. Okay. We also know there's lots of flooding. Flooding down south in England happens quite a lot. But flooding destroys crops, it destroys, again, livelihoods. People are being affected by the climate change. A lot of poor people are being affected by it because they depend on their farms, they depend on these things to live. And who are using all the fossil fuels? It's us in wealthier countries. So we need to change things, we need to do something. Now this here, switching things off, turning heat down, reducing our car journeys, recycling waste, they're all great things. We all need to do that. I think that's the bare minimum that we need to do. We need to do more. And I'm hoping that in the COP26 something comes out that helps us to do more for our country and for the people around us. All right, so think smartly. How can we change our ways of doing life so that we can impact the world for a positive change? So guys, that's the end of the lesson. Hope you've enjoyed the chat on energy and on climate change. Just at the end there, a very relevant topic to finish on. Guys, hope you have a good one, and I hope you enjoyed those lessons. I'll see you later. Bye.